Hey there, it's Workbench for Workbench Quagmire, back with day 18 of our Free Code Camp Python certification in 100-ish days. Today we're going to cover dictionaries and sets. So let's jump right in. So in Python, dictionaries are built-in data structures that store collections of key value pairs. They work very similarly to real dictionaries where you search for a word to find its corresponding meaning. With the Python dictionaries, you use a key to find its corresponding value. You should use dictionaries when you need to associate values to unique keys. This is helpful when you need to find a value fast based on the key and when you need to represent structured data. This is the general syntax of a Python dictionary. And so here we have it. It's the name of the dictionary, and then you assign it the key value pairs. First, we find the variable that holds the dictionary. You don't necessarily need to assign the dictionary to a variable, but it's very common to do this to keep it in memory and use it later in the code. Then that's followed by curly braces, which are sometimes called curly brackets, and within the curly braces, there are key value pairs. Each key is associated with a value, so you can use the key to access the value. After each value, except for the last one, there's a comma to separate the different key value pairs. Keys must be unique in the dictionary and they must be immutable data type. However, the values can be repeated and they can be different, any data type. Here's an example of a dictionary that stores information about a margarita pizza recipe. So we've given it the name of pizza. The name key is associated with the string margarita pizza. The price key is associated with the float 8.9. The calories per slice key is associated with integer 250, and toppings is associated with a list containing two strings. So in this case, we have strings as our key values. The dictionary is assigned to the pizza variable. It has four key value pairs: name, price, calories per slice, and toppings. Another alternative would be to use the dict constructor, which builds the dictionary from a sequence of key value pairs. This would be the equivalent syntax for our pizza example. We pass a list of tuples as arguments to the dict constructor. These tuples contain the key as the first element and the value as the second element. So see here, name, dict constructor, and then it's a list of tuples. All the values are the same, including tuples can hold lists. So we have a list here for the toppings. To access the values of the key value pair, you can use this syntax known as bracket notation. It's the name of the variable that holds the dictionary, followed by square brackets and the key you want to access within the square bracket. So dictionary key. In our example, if you want to access the value of name, you would write the name of the variable pizza followed by the brackets with the key name in quotes. This will evaluate to margarita pizza, the value associated with name. So to update a value, you need to add the assignment operator followed by the new value. If the key doesn't exist in the dictionary, a new key value pair will be created. In recent versions of Python, the dictionary preserves the order of insertion. This is helpful when you need to iterate over the dictionary. So in this case, we are changing the name from margarita pizza to margarita. And now that the value is name equals margarita, and then if you print pizza name, you'll get margarita now instead of margarita pizza. Dictionaries also have helpful methods that perform common operations. The .get method retrieves the value associated with a key. It's similar to the bracket notation that we've used, but its advantage is that you can set a default value so you don't get an error if the key doesn't exist. So see how that's used there. In this example, toppings doesn't exist. It will return an empty list, which is default value that we are passing here as the second argument. But if toppings does exist, it'll return the value. So pizza.get toppings, empty list. So the keys and values method returns a view object with all the keys and all the values in the dictionary respectively. So if we need all the keys, pizza.keys, And we'll return a list of all the keys. If we need values, we'll type in pizza.values and we'll get a list of the values. The view object is just a way to see the content of the dictionary without creating a separate copy of the data. The .items method returns a view object with all the key value pairs in the dictionary, including both keys and values. So you can see that here. It returns a list of tuples, just as we could create this dictionary by using the dict constructor. It returns basically the same format as you would write to create the dictionary. The .clear method removes all the key value pairs from the dictionary. So pizza.clear. And the .pop method removes the key value pair with the key that you specify as the first argument and returns its value. If the key doesn't exist, it returns the default value that you specify in the second argument. If the key doesn't exist and you don't pass a default value, a key error will be raised. So here we have pizza.pop price, and then if there is no price, it'll return 10. In this case, if there's no price, it'll return a key error because we're looking for total price, and that doesn't exist. In Python 3.7 and more recent versions, the pop item method removes the last inserted item. So that's similar to a list. Pizza.pop item. And finally, update method updates the key value pairs with the key value pairs of another dictionary. If we have keys in common, their values are overwritten. So in this example, updating pizza dictionary, the price key exists in both of them, so its value will be replaced with 15. But total time is new, so it will be added to the pizza dictionary as a new key value pair. So pizza is updated with these keys and values. This is the new dictionary with the updated price and total time. Notice how the price is now 15 and total time is a new key value pair. These are some of the most commonly used dictionary methods, but there are many more. Choosing the right one can be helpful for performing complex operations efficiently. So, first question in our little quiz questions. How are elements primarily organized and accessed in the Python dictionary? Sequential indices like a list? No. Key value pairs where the keys are unique? Yes. Using a tree-like structure similar to the file system? Nope. And using linked lists where the elements point to the next? I think choice 2 is correct. What is the primary characteristic of a Python dictionary that makes it different from a list or tuple? Dictionaries create duplicates of all key value pairs. That's not true. Dictionaries are mutable. That's true. But so are lists. Dictionaries always allow fast lookups using keys. It's true. Dictionaries can store duplicate values. That's true as well. I think it's option 3. Which dictionary method is used to retrieve a value associated with a key, provided a default value if the key is not found? So it's keys. No, keys returns all the keys. .values returns all the values. .pop removes an item. So get would be our answer. There we go. All right. What are some common techniques to loop over a dictionary? You can loop over a dictionary if you need to access and process its key value pairs. This is helpful for updating their values and applying some logic to them. Let's take a look at some of the techniques you can use. Let's say that we have a products dictionary that associates every product with its price. So here's our products dictionary. We want to offer a 20% discount on all of our products. We can loop over all the key value pairs and modify the price. So the values, keys, and items methods are essential for these techniques. We covered them briefly in a previous lesson. They return a view object with the values, keys, and key value pairs in the dictionary. You can use these view objects in a for loop to iterate over the elements. For example, you can iterate over all the values of the dictionary like this. Write a for loop. The variable price in this case, product views values to get values of the products. dictionary, a colon, and then the body of the loop where you apply any logic to the values. In this case, we are printing them. The loop variable will take each one of the values, one per iteration. So we're going to get that list of values. That's what this is going to do. And for each one, we're going to assign it the name price, and then we're going to print that value. Here is the output. As you can see, each value is printed to the console one by one. This works exactly the same for keys. If you need to iterate over the keys in the dictionary, you just write an iterator. You just need to iterate over products.keys or products directly and assign a descriptive name for the loop variable. So you could say for product and product keys, but that's the same as for product and products. By default, it will, when you iterate over a dictionary, you iterate over the keys. This is the output. Each key is printed to the console one at a time. So there we are with our keys. This works exactly the same way for key value pairs. If you need to iterate over the keys and their corresponding values simultaneously, you need to iterate over products.items. So for product and products.items, print product. And that will print the tuple of the key value pairs. So you can see here, this is the output. You get individual tuples for the keys and their corresponding values. If you want to store the key and the value in a separate loop variable, you just need to define them and separate them with a comma. Then you can use them in the body of the loop. Here we are defining a product loop variable and a price loop variable. Each one holds its corresponding value. It's important to define them in order, the key first and then the value. So for product.price or comma price, and then we get we use the same method here, .items, and then we can print product and price, and then we avoid that tuple notation because we've assigned a variable to each piece of that key value pair. This is the output. You're printing them side by side, and you can use these values as you need them in your code. Now you know more about this, we can go back to our initial example. If we want to offer a 20% discount, we would multiply each price by 0.8 and reassign its value to that of the product key. We could also round the result down if we want to work with integers. So here's our original dictionary. Then we say for product and price and products.items, products.product equals round, and then the price times 0.8. So we're reassigning the value to each of these as we loop through it, and then we print products. So if we print the dictionary, we get the key value pairs with the discounted prices. So this would be the output. And finally, if you need to iterate over the key value pairs while keeping track of a counter, you can call a enumerate function. This counter essentially acts as a sort of index or count for the element within the loop. The function returns an enumerate object, which assigns an integer to each key value pair like a counter. You can start the counter from any number, but by default, it starts from 0. Here we are iterating over the keys of the products dictionary. For product and enumerate products, print the product. So, but enumerate function also assigns an integer to each value, so we get a tuple with the integer and the key. So the product, if you leave out the enumerate, we've already seen this before, product and products, it'll give you the key, but since we use enumerate, we're going to get a tuple with the index and the key. If you need to, you can assign these values to separate loop variables. Here we have two loops, variables, index and product. This is what you will commonly see and use when you work with enumerate. For index product in enumerate products, print index product. If you need to iterate over the values, you can replace products with products values. So for price in enumerate products.values, print price. So, and then that would give you the tuple with the index and the value from the dictionary. You can assign them separate loop variables as well. So you could do index, comma price. You get the same thing. And with products.items, you get the entire key value pair in addition to the index or counter. So you get index, comma product, and enumerate products.items, print index and product, and then that will print the index and the tuple of the key value pair. In this example, we get the index followed by a tuple that contains key value of the corresponding key value pair. To customize the individual value of the count, you can pass a second argument to enumerate. For example, here we are starting the count from 1. So we just add a comma and 1 here, and then it gives us the same output, but it's a little more user friendly. Most people don't think to start counting at 0. You do, I do, but they do not. Normal people. This works in any variation we've seen so far. You just need to pass the initial number as the second argument. There are many techniques to loop over a dictionary. There are some common ways, and you'll need to choose the best one for your project. Time for our quiz. Which dictionary method, when it used in a loop, allows you to access the key value pairs stored in the dictionary? So key value pairs. Not keys, that's just the keys. Items gives us the key value pairs. The values just gives us the values, and enumerate gives us the index. So choice 2. When using the enumerate function with the dictionary items, what does the first loop variable represent? The dictionary key, the dictionary's values, the index or count of the key value pairs, and the key value pair as a tuple. So our best choice here is 3. Which method would you use if you need to iterate over a dictionary and access only the keys? Well, keys would give us the keys, values would give us the values, enumerate gives us an index, and items gives us the key value pairs. So if we just wanted the keys, we would use .keys. Let's see how we did. All right. Last section here on sets. Sets are interesting, as we'll find out here. You can't store duplicates, so they have interesting applications where if you only want to keep track of unique items, you can add them to a set, and the set will keep track of those unique items without adding duplicates. It's be handy, let's say, in a menu where users were able to put values in, and then you were to reflect that back in a menu of some sort, but you don't want that to be duplicates of that, where the users may need duplicates. So sets are one of the Python's built-in data structures. One of the core characteristics of sets is they don't store duplicates. If you try to add a duplicate value to a set, only one of them will be stored. Sets are mutable and unordered, which means that their elements are not stored in any specific order, so you cannot use indices or keys to access them. They can only contain values of immutable data types like numbers, strings, and tuples, and they support mathematical set operations, including union, intersection, difference, and symmetric difference. To define a set, you just need to write its elements within curly braces and separate them by commas. This is an example of a set of numbers. So my set is assigned to a set of integers here. One quirk of working with sets is that if you ever need to define an empty set, you must use the set function. If you just write an empty curly braces like that, Python assumes you're creating a dictionary because obviously the syntax is basically the same or very close. So set gives you an empty dictionary or a set, and the curly braces give you a dictionary. You can add elements to the set using the .add method and pass in the new element as an argument. So if my set.add 6, so in our example would be 1 through 5 now with 6 included. If you try to add an element that's already in the set, only one will be kept. In this case, we already have the number 5 in the set, so if we type set.myset.add 5, we will still only have 1 through 6. To remove an element from a set, you have two options. You can either use remove or the discard method and pass in the element that you want to remove as an argument. And that works because they're unique items. So you can't use an indices. So the remove method raises a key error if the element is not found, while the discard method will not. So we say my set dot remove for, and then my set discard for. The clear method removes all the elements from the set, so we can clear it out. Python also has powerful methods that perform common mathematical set operations, like is subset and is superset methods. Check if a set is a subset or superset of another set, respectively. Here we're checking if your set is a subset of my set, which is false because not all of the elements of your set are in my set. We're also checking if my set is a superset of your set. This is also false because my set does not have all the elements of your set. So my set is 1 through 5. Your set is 2, 3, 4, 6. So print your set is subset of my set. That's not true. And my set is not a superset of your set. It would be if there was a 6, but there's not. The is disjoint method checks if two sets are disjoint, which means they don't have any elements in common. In this case, that's false because my set and your set have the common elements of 2, 3, and 4. So if you print my set disjoint your set, it's false. The union operator returns a new set with all the elements from both sets. The intersect operator returns a new set with only the elements that the sets have in common. So in this case, it's 2, 3, and 4. The difference operator returns a new set with the elements of the first set that are not in the other set. In this example, 1 and 5 are not in your set. The symmetric difference operator returns a new set with the elements that are either in the first or second, but not both. So in this case, it'd be 1 and 5, and then also 6. Those are the uncommon elements. Each one of the operators also has its corresponding compound assignment operator if you add an equal sign next to it. These operators automatically assign the resulting set to the first set in the expression. So for this example, the minus equals operator finds the difference between the sets and updates the first set with the result. So my set minus equals your set. And so it's just going to change my set to, instead of 1 through 5, to 1 and 5. You can check if an element is in a set or not using the in operator. Here we're checking if 5 is in my set and the result is the Boolean value true or false. 5 in my set, that would be true. And those are the fundamentals of sets. They're very helpful when you don't need to store the values in a specific order and when you only need to store unique values. Here is our quiz. So which of the following is a core characteristic of a Python set? Elements are ordered and accessed by an index. That's false. Elements are stored as key value pairs. That's also false. Elements are unique and unordered. That's true. Elements can be of any data type, including lists and dictionaries. It's not true because they have to be immutable objects, so strings, integers, tuples. So 3 would be the best choice. What operator is used to check if an element is present in a set? It'd be double equals? No. Yes. It'd be in, get, find. We didn't even talk about get and find. So in. Which set operation returns a new set with the elements that are present in either one of the two sets, but not in both? And that would be a union, no. That's where you add them together, and it contains all the items from both sets. The intersection would be all the items they have in common. The difference would be the items that were not in the second set, but were in the first set, and symmetric is all the uncommon items. All right. Let's see what's going on tomorrow. Modules. It's checked off here because I've already gone through it, but we'll go through it together tomorrow. We'll cover modules. So thanks for watching the video. Don't forget to like, subscribe, and comment, and I'll see you later.